We first open this accessory box. There is this power cord in the accessory box. Then the foot switch. Trachea. This is the factory test report and manual. Certificate of conformity, and then this is a special wrench. And a screwdriver. Plus this tracheal joint. It is used for trachea transfer. Our main thing is to connect the power supply. The air source and foot switch are on the side of the instrument. First, plug the power cord into this position. Then plug it into 220 volts here. Take out the foot switch and connect it to this position. To click. And this is the trachea. The other end is connected to our compressed air source. The gas source should be larger than 400 billion Pa. This is the total power supply of the instrument. Just push it up. And then here is the switching power supply of the instrument. Press. This is the overall appearance of our instrument. We broke it down into these parts. This is the intake adjustment. It is the air source that comes in to adjust the air pressure. And then there's the display. This is the cylinder. This is the upper air knife. The bottom part is the downwind knife. Our upper wind knife is divided into 5 independent temperature control modules. We have 5 hot air meters. 1, 2, 3, 4, 5 temperature control ranges. Then add a downwind knife. There is a hot air time to test the pressure. Our testing model. Divided into automatic mode and manual mode in terms of temperature control device settings. We can set the hot air time. For example, I hot air a sample. I set it to 1 second. The hot air will automatically return in a second. And then we can set the different temperatures of 5 air knives. For example, the temperature of the upper air knife is still the temperature of the first air knife. We can set it to 100 degrees. The second temperature I can set to 110 degrees. The temperature of the third hot air knife can be set to 120 degrees. The fourth one I can set to 130 degrees. We set different temperatures according to needs. Then the temperature of the downwind knife is generally fixed. 100 degrees can also be set to different temperatures. Take out the sample to be tested. Divide it into horizontal or vertical cutting. according to your experimental requirements. Set the temperature and hot air time of the upper and lower air knives. Then return to the test interface point temperature control. Our setting value is 100 degrees. It will reach the target temperature of 100 degrees. Set to 130 degrees. Its target temperature reaches 130 degrees. The temperature of his 5 air knives, you can set it to the same, or it's different. This is based on your testing requirements. And so does time. It is also set according to your requirements. Same with stress testing, determined according to time requirements. The way we adjust the pressure is to pull the knob up. Twist clockwise to increase pressure. Counterclockwise to reduce pressure. Demonstrate. Turn clockwise. And you can see the pressure building up. Then turn counterclockwise to seal the knife and press it down. After it is pressed down, it will have a process of relieving pressure. It will slowly stabilize. When the temperature of our hot air knife reaches, you can sample the hot air. We divide the hot air sample into several ways. There is an automatic. What do you mean automatic? That's the time I set. I pressed automatic. It will continuously press down. Manual means that I press it manually. He will press down, then we click stop. He'll bounce up, but he doesn't work continuously. Our samples are generally two films. Let the two films fit together. Then put it in the hot air position. Step on the hot air switch. Then our hot air magic color. You can take it to the tension machine for testing. Then the remaining samples are equally hot air. Because the most important thing about our instrument is temperature, next we will demonstrate temperature correction. We need to use high-precision thermometers. Then use this probe. Put it in the position of the 5 sections. To measure separately, its set temperature and actual temperature. Is it the same as the displayed temperature? We need to change the downtime for correcting the negativity. Change the hot air time to 1 minute in the settings. Then return to the test interface. Then put our temperature probe. Put it under the pressure of the hot air knife. Manual buttons on the instrument screen. Then hold down. And look at this thermometer that we have here. The actual displayed temperature. After it stabilizes, is it consistent with the temperature we set? Hot air knife 1, if it is consistent with the actual displayed temperature. We don't need correction. If our temperature deviates, we click the correction button and press the password 1918 to enter. After entering the correction interface, we will have independent correction parameters for 5 air knives. Calibration parameters of 5 air knives. It is further divided into correction values A and B. The difference lies in the different correction intervals. The correction interval L is 100 degrees as the correction point. The correction value B is 150 degrees as the correction point. And the difference that we correct for is this correction factor. This correction factor is based on E. Then our temperature is said to be low. We're going to subtract this E, the temperature we are lower. Then if our temperature is too high, we're going to increase this coefficient E up. The increased temperature is the correction point, in order to meet our calibration target value requirements. After we did the experiment, that is to say, we would not be using this device today. We're going to turn off the temperature control. Air pressure screw down, set it to 0. We're going to turn this device off first. Then turn off the main power. Tension down. Then the entire instrument installation operation demonstration is completed. We are in the process of testing samples. If the sample hot air is found to be uneven, we need to use copy paper and 2 sheets of A4 paper. To determine when the furniture is pressed down, uniformity of hot air density of upper and lower air knives. Then we can take a look. The uniformity of this hot air. If there is no unevenness, there is no abnormality. Suppose there are different shaded parts. Words of different shades. Maybe it needs to be adjusted. The flatness of the hot air knife. If the pressure is uniform, it can be tested normally.